Everyone, we are excited to present a project titled Personalized Workout Recommendation System. With growing interest in health and wellness, many people today want fitness plans that are tailored to their bodies, goals, and lifestyle, not just generic advice found online or from fitness app. That's where our project comes in. We have developed a machine learning based system that creates custom workout recommendations for individuals, helping them make better informed fitness decisions based on their health status and personal data. The primary goal of our project is to develop a personalized workout recommendation engine using machine learning. We built a predictive model that takes in basic personal and health related information and outputs a complete personalized workout recommendation. Specifically, the model predicts four aspects. First one is the fitness goal, such as weight loss, muscle gain, or general fitness. The second is fitness type, like strength training, cardio, or flexibility based workouts. Third one is specific exercise, for example, push ups, cycling, or yoga. Fourth is recommended equipment, like dumbbells, resistant bands, or treadmills. To make our recommendations smarter, we didn't stop at prediction alone. We also implemented collaborative filtering, a technique used in recommender systems like Netflix or Spotify to suggest exercise based on what similar users have followed and found effective. This combination of predictive analytics and collaborative recommendation makes our system robust and user centered. The data sets which we have used is to build any effective machine learning model. You need the right data. We used a real world gym recommendation dataset which includes multiple features relevant to fitness planning. Here is what the dataset includes. First one is demographic information like gender, age, height and weight, all fundamental to building a workout plan. Second is the health condition such as whether the person has hypertension or diabetics, which are essential to ensure safety during physical activity. We also derive BMI, which is a body mass index, from the user's height and weight. This helps the model access body composition. The dataset also contains target labels, which are the outcomes we are trying to predict. The fitness goal, type, suggested exercise, and the equipment. Before using the dataset and the model, we processed it carefully. Categorically variables were handled with encoding techniques, and numerical features were normalized to ensure equal importance and avoid bias in training. What are the approaches we used in this project is we followed a structured machine learning pipeline which includes multiple steps from data preparation to model training. Here is what we did. First one is one hot encoding was applied to categorically input features like gender or health status, transforming them into binary vectors. Second is target labels, which are multi output. We use label encoding to convert them into integers. Third one, we applied a standard scalar to normalize all numerical features such as age, height, weight, and BMI. This ensures all features are on the same scale. The dataset was split into 80% of training and 20% of testing to fairly evaluate the model. We trained a multi output logistic regression model. This means the model can predict multiple outputs fitness goal, type, exercise, and the equipment simultaneously. We also developed a manual input interface. This allows users to enter either own data and the model provides instant prediction tailored to them. Finally, we encrypted and collaborative filtering using K nearest neighbor. This part of the system identifies users with similar fitness profiles and recommends exercises that those users liked and followed. It adds a human like touch to the recommendation. Then the model selection. Why we choose the models and techniques that we used. We choose logistic regression, a widely used classification algorithm known for being simple, fast, and highly interpretable. Because we had to predict multiple outputs, not just one. We wrapped it inside a multi output classifier, which allows the model to handle all four predictions at once. To make sure the features fed into the model were balanced and comparable, we used standard scalar for normalization. For the collaborative filtering component, we use the K nearest neighbor algorithm. It works by finding users in the dataset with the most similar fitness characteristics and recommending exercises based on their preferences. Together, these choices make the system accurate, efficient, and suitable for real time prediction. The evaluation metrics. The evaluating the performance of our system was a crucial step. We used several metrics to assess how well the model performs. First is the accuracy score. We computed accuracy for each of the four prediction categories to understand how often the system is being encouraged was correct. Classification report. This report gives us the metrics like prediction, how many of the predicted results were correct. Then recall how many of the actual positives were identified. And F1 score, a harmonic mean of precision and recall. We also compare training and testing accuracy to evaluate how well the model generalizes to new data. This helps detective overfitting when a model performs well on training data but poorly on new unseen data. Together, these metrics give us a clear picture of both the strength and limitations of the system. Manual user inputs. One of the highlights of this project is the real time user input functionality. The system allows any user to input their basic fitness and health details directly. These include such as gender, age, height in meters, weight in kilograms, hypertension status and diabetes status. From the height and weight, the system automatically calculates the BMI. Once all this information is entered, the system predicts the user's ideal fitness goal, workout type, appropriate exercise, and necessary equipment. But there is more. The system also checks for users with similar profiles and suggests exercises that they have used and thanks to the collaborative filtering component. This real time interactivity makes the system not just predictive but also adaptive, making it suitable for use in apps or fitness consultation. To conclude, a personalized workout recommendation system is an effort to blend health data, machine learning, and recommender system into a tool that can genuinely assist people in their fitness journey. We believe that personalized plans are more effective, engaging, and safer for user, especially when built using thoughtful algorithm. Thank you for your time, and we are ready to present our demo. Yeah. This is a demo of a project where it involves the analyzing user fitness data and predict the personalized exercise recommendation using both classification models and collaborative filtering techniques. First of all, we load the data for pre-processing, such as we begin by importing essential libraries like pandas, numpy, sklearn, and matplotlib. Then we load the dataset from an Excel file. Then we select the feature. From our dataset, we select input features like gender, age, height, weight, hypertension, diabetes, and the BMI. Then we get a target output such as fitness goal, fitness type, fitness exercises, and the equipment. Then we start encoding the categorical variables such as input features. We apply one hot encoding to variables like gender, hypertension, and diabetes so that we get an output label. Each target column is label encoded to numerical values for model training. Then we start with a feature scaling. We use a standard scaler to standardize the feature values. Then we start to train and test the data. We split the data for training and the evaluation. Then we used to train the multi output classification using a logistic regression for predicting all four target outputs simultaneously. Then we start to evaluate the model. After prediction, we evaluate the following model using the accuracy and classification reports for each output column. The classification output reports show very high accuracy for most outputs. For fitness goal and type, it shows 100% accuracy. For exercise, it shows 100%, and for equipment, it shows 89%. Then here comes for the real time prediction and the collaborative. where we also built an interactive user input system where a person can enter whether there is a male or female, then their age along with their height in meters, then we will enter their weight in kilogram, then we will enter whether they have hypertension or not, then it asks us for about the diabetes status, and finally it gives evaluate the BMI and predict the recommendations using the trained model. Additionally, we use the k nearest neighbor for collaborative filtering. It finds users with similar profiles and recommends exercise based on their habits. The combined output gives predicted plan for the model and collaborative recommendation based on the neighbor. Then we get an accuracy summary. We also compare the training test accuracy for each output feature. Then we get a learning curve. To understand model learning behavior, we plot learning curves for each target. Shows how accuracy evolves with increasing training size, helps identify underfitting or overfitting. Each learning curve is plotted using Matplotlib, providing insights into generalization. Finally, this system demonstrates the power of multi-output classification, collaborative filtering in creating intelligent, user-centered fitness recommendation. The high accuracy metrics indicate that the model performs well and could be further integrated into a mobile or web application for the practical use. Thank you for your time about learning the project what we have done.